Hey guys, so what we're going to do is start our physics unit. We're going to start by doing a little bit of a review of Science 10 physics. I'll go through some example problems and then you'll try some on your own. I will also have these slides posted on Moodle in case you'd rather look at them there or in case you have troubles with the video. So let's take a look. So a little bit of review of Science 10. So one of the first things we're going to start with is the difference between scalars and vectors. So remember, you have two types of quantities. You can have scalar quantities and you can have vector quantities. And the difference here is that scalar quantities have a magnitude or a size only, and vectors have got a size or a magnitude and a direction. So they include a direction instead of just having a size. In general, if we have vectors pointing to the left or pointing up, they'll be positive. Left or down or to the left are going to be negative. And in general as well, if we have our compass directions, north and east are going to tend to be positive. South and west we're going to usually set as negative. Remember too that vectors get a little vector arrow on top, a little vector harpoon that sits on top of them there. So let's try an example. So if you walk 305 meters to the west and then you turn around and walk 200 meters to the east, what's your distance traveled and what's your displacement? So we like to start these with a vector diagram. So the first direction we're going is west, so we'll draw that to the left. And we went 305 meters to the west. Then we went from here 200 meters back towards the east. So if I want to find my total distance, remember that's our scalar, so that's just going to be the total path that we walked. We went 305 meters plus another 200 meters. So that is 505 meters total is my distance traveled. Your distance is like your odometer on your car. It always counts up. But the displacement, that's the distance, or that's where you end up relative to where you started. So we started up here. We went 305 meters. We went 200 meters back to the east. So we ended up standing right here. And we started over here. So we didn't go a total of 500 meters this way. That would put us out here somewhere. We only ended up 305 meters minus 200 meters back this way. So we only ended up 105 meters away from where we started, and we ended up to the west of where we started. So because these are in opposite directions, we can subtract them. 305 meters minus 200 meters. That gives us 105 meters to the west is where we actually ended up. And that's my displacement, which we can show with a vector arrow over the D. Now, what if I take my dog out for a walk around the block? So here's my block. What's my distance? What's my displacement? So regardless of where I start, if I go around the block, that means I went 100 meters this way, went 100 meters this way, went 100 meters this way, and then I went 100 meters this way. So my distance traveled is 100 meters plus another 100 meters plus another 100 meters, plus another 100 meters, right? All of those paths. So I went 400 meters as my distance. But my displacement, so that's where did I end up relative to where I started? Well, I started here, I ended up here, so my displacement is 0 meters. My distance was 400 meters. Now, in your data booklet, you'll have some of your units listed for you. So some common units that we'll use will be speed and velocity. So speed is the scalar, velocity is the vector, right? You can recognize that because velocity has got the vector arrow. Speed doesn't. Distance is scalar. And displacement is vector. We'll use the unit of time, which is always scalar, and acceleration, which is always going to be a vector. And you'll have to do some unit conversions here too. We went through how to do those and reviewed that in our chemistry unit, and I might post a separate video with some reminders for how to do that. But here's some of your common unit conversions that you might have to do. And on page 2, you also have some formulas. So the first formulas that we're going to use here are v equals d over t. So that's my speed is distance over time. This is the vector version of the formula, with velocity is equal to displacement over time. And then acceleration can be found like this. I like using vf minus vi over t. Remember, the f is the final, the I is the initial, and the t is the time. So for solving problems, this is the way that I like to go through and do it. I'm going to list what variables I'm working with. I'm going to convert any units that I need to. I'm going to write up my formula. I'm going to rearrange it if I need to. And then I can substitute in my values. I always make sure to include units when I do that. And then I have my final answer that I report with the right number of sig digs. And I don't forget about the final units. Let's go through a couple of examples. So a car travels 1,300 meters in 31 seconds. What's the speed of the car? So let's start by picking out what these numbers are. So this number is in meters. So that is a distance. Takes 31 seconds. That's a time. And then I'm looking for the speed of the car. So my speed is what I'm trying to solve for. I know my distance, 1,300 meters. I know the time, 31 seconds. So V equals d over t. I'm looking for V. It's already by itself, so I don't need to rearrange this formula. So I don't need to do any algebra. I can substitute in my numbers. 1,300 meters divided by 31 seconds, which I can then solve. I found a super fancy dancy graphing calculator emulator. So we can turn this guy on. Come on. There we go. So 1,300 meters divided by 31 seconds gives me 41.935 meters per second. Now let's look at how many sig digs I get. This number's got 4 sig digs. This number only has 2, so I get to report 2 digits. So that means I need to round to this place where the 1 is. And next to it is a 9, so that's going to round up to 42 meters per second. So I have my proper units in there. I've rounded to the right number of sig digs. Now what about this one? A car travels at 45 kilometers per hour west for 100 seconds. What is the car's displacement? So this is my velocity because it includes a direction. This is my time. So my variables here, v equals 45 kilometers per hour west. My displacement is what I'm looking for, and my time is 100 seconds. Now I've got to watch this number because I'm going to have to convert that into meters per second. So let's give ourselves a little bit of room so that we can do that. So we can remember the conversion factor of 3.6, but if I want to do it with unit canceling, I would put in a ratio first to cancel my kilometers. So if I want them to cancel, I need to put them on the bottom, and I want to turn them into meters. Now, how many meters are in a kilometer? Well, there are 1,000 meters in 1 kilometer, and that's going to cancel my kilometer unit. That would give me meters per hours, but I want meters per second. So I need to get this hour to cancel. So it needs to go on the top so that it's going to cancel with itself here. I want to turn them into seconds, and I know that there are 3,600 seconds in 1 hour. So then the math I need to do here is I need to multiply across the top 45 times 1,000 divided by 3,600 gives me 12.5 meters per second as my velocity in meters per second. So that number is what I'm actually going to use when I need to solve for this guy. So my formula here is v equals d over t. I need the vector version because I'm looking for displacement and I have velocity. And I do need to rearrange this formula. So v equals d over t. I want to get d by itself. So what's keeping d from being by itself? Well, this t down here. So to get t to cancel, I can multiply by t on this side. Now it will divide by itself and cancel. But if I multiply by t on this side, I have to multiply by t on this side as well. Those guys will cancel, and my new formula will be d is equal to v times t. And I have both of those numbers. I'm going to remember to use the meters per second velocity, 12.5 meters per second, times my time of 100 seconds. I can multiply those two values together. Let's scooch this over a little bit. So 12.5 times 100 gives me 1,250. Now I'm only allowed 2 sig digs here, so let's write this down, and then we're going to have to use some scientific notation. So our d was 1,250. Double check I'm remembering that right. Yep, 1250. And the units here would be meters, because that's the part of the d that I plugged in. So that's my displacement. But I need to round for sig digs, so I'm only allowed two digits. So the decimal's right here. 1, 2, 3. I could move it up 3 spots. That lets me round to 1.3, because there's a 5 next here, times 10 to the power of 3 meters, and I need to include the direction west. Here's my final answer. Okay, now I think I'm going to skip this one. I'll put it up if you want to see what the answer is, but I'll skip it for now. We just have to do some unit conversions before we look for the velocity. And let's do this one because we have to rearrange for time, which is a little bit tricky. So a ball rolls at 6.5 meters per second. That's a speed over a distance of 10 meters. That's a distance. We want to find the time. So I've got my v, got my d, I'm looking for my t. Now, this is a tricky one because I'm trying to isolate t, which is on the bottom of the fraction. So I have to get it up to the top of the fraction before I can rearrange. So let's do our algebra. V equals d over t. I want to get the t up to the top of the fraction. I'm not going to worry about getting it by itself yet. So to get t to the top of the fraction, I can multiply by t on this side. I can multiply by t on this side. These guys are going to cancel. So that will give me t times v equals d. Now to get t by itself, I can divide by v, which will cause it to cancel, divide by v here, and that will give me t is equal to d divided by v. I have those numbers, so I can plug them in. My d is 10 meters divided by my v, 6.5 meters per second. Let's see what that gives us. 10 meters divided by 6.5 meters per second gives us 1.538. Now we get two significant digits, so we can round to this 5 place, and that'll give us 1.5 seconds as my time. That's got the right number of sigdigs. Okay, we'll skip this one too. I'll put the answer up for you. And that's just another time one. Now let's try an acceleration. So for number 6 here, we have a bike. It starts at a velocity of 3.5 meters per second and increases velocity to 7.1 meters per second over 55 seconds. What is its acceleration? So this is my starting velocity, VI. This is my final velocity, my VF. And this is obviously my time. Then I'm looking for acceleration now. So for my formula, I'm going to use A equals VF minus VI over T. I'm looking for acceleration. That's what I have, so I don't need to rearrange this formula. We can just plug in. We're going to make sure we put the things in the right spot, though. So my VF is 7.1 meters per second minus my VI, 3.5 meters per second, divided by my time, 55 seconds. Let's fire that in and see what we get. So 7.1 minus 3.5, then we're going to divide by 55. That gives us a pretty small acceleration. So how many sigdigs do we get? This number's got 2, this number's got 2, this number's got 2, so we get 2 sigdigs. Now this 0 is to the left of the first non-zero number, so it doesn't count. It's not a significant digit. So we're going to include this 6, and we're going to include this 5. There's a 4 next to the 5, so it doesn't round up. So 0.065 is going to be my value. 0.065. And then this is an acceleration, so the units are meters per second squared. And you got to watch those units because it's easy to get the wrong units for accelerations. Then if we're solving for time here, so I'll just walk you through how to solve for time. How long does it take for a jet to accelerate at 50 meters per second squared and undergo a change in velocity of 450 meters per second? So that's a delta V. So here we can use the version of the formula A is equal to change in velocity over change in time, which will make it a little bit easier to rearrange. So I want to get t by itself. You'll see it's kind of like that uniform motion formula that we used earlier. First thing I want to do is get the t to the top of the fraction. So if I multiply by delta t on both sides, it'll cancel over here. Then I can get the a to cancel by dividing by acceleration on this side, as long as I divide by acceleration on this side too. This guy will cancel with this guy, and that'll leave me with delta t is equal to the change in velocity divided by the acceleration. I've got both of those numbers. The change in velocity was 450 meters per second, and the acceleration was 50 meters per second squared. People sometimes have a difficult time finding the difference between accelerations and velocities, and so one trick that you can use is to look at the units. Units of speed or velocity will always be distance over time, meters per second, kilometers per hour. Accelerations will be distance over time. The time will be squared. So this is a distance over time squared unit for the velocity. That's one way that you can tell the difference. Now we can do our final solve here. So 450 divided by 50 gives me 9 seconds. And we do get 2 sig digs, so 9.0 seconds, because my calculator just showed me 9. Then finally, the last type that we might have to do here is to figure out the VF, to figure out the speed. So the final speed. So if we have a car here that's accelerating at 5.0 meters per second squared, so that's my acceleration. Starts at 3 meters per second squared. That's a VI. How fast will the car move after 12 seconds? So that's the time, and I want to know how fast is it going then, so I'm looking for my VF. Okay, so my formula that I'm going to use is A equals VF minus VI over T. I want to get the VF by itself, so I have to get T and VI out of there. Start with the T. To get the T to cancel, I can multiply by T, multiply by T. T's will cancel with themselves here. And then to get the VI to cancel, I can add it because it's being subtracted from the VF. So I'd go plus VI to this side, plus VI to this side. And then those guys cancel. So here's my formula. VF is equal to VI plus T times A. So the VF is equal to the VI. So what was that? That was 3.0 meters per second plus my time, 12 seconds, times my acceleration, 5 meters per second squared. Let's plug that in and see what we get. So 3 plus, I'm going to open a bracket, 12 times 5. That gives me 63 meters per second. And I get 2 sig digs. So my VF will be equal to 60, what was it here? 63 meters per second. I'll include the solutions for the ones that I skipped over on the website, so if you want to see those, you can find them there. Let me know if you have questions.